Well, thanks for having me. I'm Matt. I'm the technical manager for Chef for Asia, Pacific, Japan. Man, that's big. I'm based out of Sydney. I moved over here about a year ago, and I've been back and forth New Zealand, Japan, Singapore, all over the place. So I'm over here for a fair amount. We have a couple of big customers over here in New Zealand, so I get to visit them a lot. But I've been a chef for about 7 years, and if you've been involved in chef, that's a long time. I was employee 16, so that's way back. So that's how you get a hold of me if you need anything. Before I moved to Australia, I ran partner engineering for Chef, and so that's the engineering team that works with Amazon. So I've got a little bit of background with the whole OpsWorks offering, and I'll talk about kind of the history of that as we go. It's not just tech; it's about the people and all that fun stuff. And if anybody has any questions, please interrupt me because I'll just ramble on and monologue, and that's boring. The reality is, most enterprises are going to. We got this nice quote from Andy Jassy from AWS at reInvent last year. He said most enterprises are going to operate in a hybrid fashion for many years to come. And then he started talking about VMware, right? And the fact that Amazon is doing a great job of capturing all that public cloud, but they know that back inside the data centers, there's still money to be made. That's essentially how they work, right? And one of the things that's kind of evolved over the years is Amazon has said, they launched their OpsWorks project in 2013. And they've said a lot of nice things about Chef over the years, both OpsWorks as well as their own, as well as kind of our version of Chef. And one of the things they said in 2015 was 60% of their enterprise users are using Chef. So they had identified that the really large customers that they have are probably using Chef, and they're a consumer of this as well. And over time, the way you're managing your infrastructure has been changing. You've probably noticed, it's not about keeping servers running anymore. Now it's moving into more about, giving developers the infrastructure they need to operate and moving faster. And so, the stuff you're managing is starting to change, and Chef is starting to change in relation to that. And really, what businesses are about today is getting features to customers faster. That's it. When you talk about an airline or a shipping company or a supermarket, at the back end, they're a software company. And what we want to help them do is make that transition from thinking about themselves as an airline or whatever to a software company that puts features in their customers' hands faster. That's it. That's all we're about. And so we want to help people increase the speed and efficiency that they work at while reducing risk. And so we'll kind of see how that works. So Chef Automate is our commercial offering, right? This is the commercial offering from Chef. It's the only thing we sell. We only have one thing we sell, and it's built on top of 3 open source projects. And I'll talk about each of these: Chef, Habitat, and Inspec. And the cool thing about these is they're all completely open source, Apache licensed. You can do whatever you want. And a lot of people take these and embed them in their commercial offerings. Amazon took Chef, and they bought a small German company that was building a PaaS offering on top of Chef, and they bought them. 9 months later, they said, OpsWorks is now a thing from Amazon, and you can get managed Chef directly from Amazon. They called us the week before they launched it and told us, guess what? And so that was kind of like, uh-oh. And this is a kind of a thing that is happening with open source businesses these days, right? They're going through this phase of realizing the plan of having a SaaS offering of your product, kind of when you run into the likes of AWS and Google and Azure, they're going to take your offering and offer it as a service, and the customers don't want to pay 2 vendors, right? The customers are like, I'm already paying Amazon $100,000 a month. Why would I give you guys $1,000, right? I just want to have this AWS bill. I don't want to deal with 2 vendors. And so that's kind of an evolving thing with open source businesses, and everyone's kind of going through this process. But I'll talk about that when I get to the OpsWorks slide. But Chef Automate, it's the only thing we sell. And it's based on these 3 projects. The first of which is Chef, right? Everyone knows Chef? Anyone using Chef? Yeah? Anyone not know anything about Chef? Thanks for coming. So Chef is configuration management. This is the idea of infrastructure as a code. Everything on your systems is going to be managed in software. So anything that you think a sysadmin should be doing should be done in software. And so the way we do it at Chef is we have what we call resources, things like packages and templates and services that represent the things on a system that sysadmins care about, right? And rather than have you say, I need to install Apache with apt-get install -y Apache -v for the version you want, you just say package Apache, right? And likewise, you don't have to know the yum command or whatever the OS level command is. We try to abstract you away from that, give you some abstractions that work with a couple parameters that let you say, hey, I need this particular version, or the file that I'm putting down, this templatized file, it's got these permissions and so on by this person. Just high-level abstractions for the things you're going to manage. Chef is written in Ruby though. So rather than only give you resources that represent those things, we said, hey, chances are good you're going to need to do something complex at some point. Maybe you'll talk to an API. Maybe you'll calculate something on the fly, or you'll need to, target APIs is a good one. So we give you Ruby. We give you the flexibility of having a full-blown programming language that's open source, that has hooks into lots of stuff, in case you need that. You don't always need it. In our training materials, we have a section called Just Enough Ruby for Chef. It's pretty short, because most of the time you're going to have code that looks like this, where it's just, service, package, directory, service, template, and go. And there's other open source tools. There's Chef, there's Puppet, there's Ansible, there's Salt. They're all kind of this, third generation of config management tools. And there's subtle differences between how each of them work. When Chef got started, it was written by Adam Jacob, our current CTO, and he'd been using Puppet. He'd been using Puppet at a consulting company, and trying to get it to scale to certain sizes and become more reusable. Had some issues with the way it worked, and decided that he'd rather write his own tool. Right, it's the whole open source thing. I can write something, and he showed it to a couple people. One of them was Jesse Robbins, who's the director of operations for EC2, and Jesse said, "That's cool." He also showed it to Chris Brown, who's one of the architects for EC2. Chris was at the time working at Microsoft as the architect of Azure. And he showed it to them, and they said, "That's great. We want to start a company with you." Right? So rather than just have this open source project and kind of leave it there and just use it for a consulting company, they went out, raised some capital, started a company, and that became OpsCode. 2015, we changed the name to Chef, because people would say, "Who's OpsCode?" And so we went with the whole name recognition thing. Worked for Oracle, worked for Docker. It's working for us. So we did change the name. So Chef is out there with a couple of other open source projects. A lot of our early customers were the big web companies. Shops like Facebook, Yahoo, Etsy, Heroku. People who had a lot of infrastructure, but not a lot of variety. Right? They had, like Facebook has one app, and they went on, million servers or so. And so, people who had kind of boring stuff, but those lessons at scale, we brought them down. We tried to come up with the abstractions that work best for smaller deployments. Maybe only have 5,000 nodes. But a lot of that scaling work went into the product. Facebook insisted that we open source all the scalability stuff, and we said yes before they finished the question, because we'd already planned on doing that. So everything about Chef is open source. There are no limitations on it. Like I said, people embed it in a lot of other products. It gets embedded by IBM, by Oracle, by Amazon, and others. But it's really good at scale. One of the other things it's really good at managing is Windows. I was told that Microsoft is kind of persona non grata around here, but the reality is like most shops are heterogeneous. Most people are going to have a mix of Linux and Windows, or they might say we're a Linux shop except for those Active Directory boxes, or we're a Windows shop except for the web servers. And so most shops were heterogeneous, and with having our headquarters in Seattle, founders from Amazon and Microsoft, we hired Microsoft engineers, and we started actively supporting all of the Windows features. So when Microsoft introduced DSC, this is their desired state config. This is how Microsoft is telling you they want to manage their applications. We immediately added support for that, where we discover the resources they expose and generate handlers for that automatically. Microsoft took notice of that. Today, they are one of our largest customers. We manage Azure, parts of Azure, MSN, Bing, Office 365. So we can do Windows pretty well. Microsoft contributes directly to the Chef code base. Pretty much at this point, whenever they release a new feature, we've been working on it with them because they're becoming much more open source friendly, which is a change of pace. So yeah, scale, Windows, but also testing. Testing is one of the things that kind of differentiates Chef from other tools. When we started going down this path of infrastructure as code, we realized that it's great to have this code, but one of the things that developers do is anytime they make a change, they test it. Right? They have CI pipelines like tools like Jenkins that are going to go and validate that the changes that they've made aren't going to break the application. So the first book about Chef is actually called Test-Driven Infrastructure with Chef. And so we have unit tests, lint tests, syntax checkers, lots of automated testing built in with the Chef Developer Kit. We also make sure it works well on Windows because that's where a lot of operations folks are. And we have an integration tool called Test Kitchen, and I'll show you that in a little bit. That makes it easy to test your infrastructure on your laptop using Vagrant or AWS or what have you. So that's Chef, config manager. Any questions about Chef? We also do like Solaris and AIX and OSX and pretty much any commercial OS at this point. Anything? All right. So that's what most people know us for. About 2 years ago, we acquired a German consulting company that was doing auditing compliance for Deutsche Telekom. And one of the things that they realized is they were going through these big, massive binders of paper and PDFs and Excel spreadsheets. Anybody deal with auditors? Right? You know what I'm talking about. One of the things they realized was a lot of these requirements could be represented as tests. You could write tests that say, you get that hardening guide that says, these 17 surfaces can't be on a system, right? When you deploy MySQL, this user should not be there. MySQL ships to the default user. And so when they came on this realization, they said, hey, the spec framework is a really good testing framework. Let's turn those tests into code. And so let's do compliance as code. And so we liked what they were doing and acquired them and open sourced InSpec. And so InSpec is completely separate from Chef, right? It does not use Chef. It does not require Chef. It is a domain-specific language that looks like this. It has very human-readable syntax. This is an example of, do I have 2 slides of this? No. I've got a Windows version of this too, but where you've got syntax like, I'm looking at my grub conf, the bootloader for Linux. I expect grubconf, the SE Linux parameter not to be set to 0. I expect the forcing not to be set to 0, right? I want SE Linux turned on. This is the kind of thing you might have in a hardening guide. You might have a list of services that you want, where the syntax would be expect service not to be installed, right? That's pretty human readable. And so you take these controls, these requirements, you hand that PDF, that binder of paper to junior sysadmin on his first day, or your auditors. They can write this. It's pretty high level, and you say, let's turn that into code. And when it's code, you can start testing it, right? You can put it into your CI/CD pipelines. You can evaluate the state of your infrastructure actively. You can go out and scan machines and see if you are compliant to your hardening guides that you've got, rather than wait for the auditor to show up and then you're running around as they say, well, this is turned on and this is turned on, and you turn those off, and then they leave, and then they magically turn back on right after they leave. You want to make it part of everything you do. You want to scan for compliance, find the things that are broken, fix them, and then make sure that it doesn't happen again, right? So you don't have somebody turning Figure back on, or Telnet, or something that's got all sorts of vulnerabilities. And so Inspect is both a language. Here's the testing part, but it's also got the high-level things that an auditor would want, like the impact of something. Is it critical? Is it trivial? Right? Can you just ignore a bunch of things, or can you not go out the door with certain things turned on? You can do title, your description, some tagging, and so these controls become code. You version them, you fork them, you share them, you put them on GitHub, and the Inspect command line can work remotely. It uses SSH, uses WinRM, can also work with Docker. Connect to the Docker host, scan the running instances that are on it. And so that's what Inspect's about. It's been very popular, Apache licensed again, so it's fully open source. It's got contributions from HP, IBM, Microsoft, Oracle, and then we recently added support for databases, APIs, and cloud platforms. So what that means is rather than just look at a server and see if the users aren't there, you can actually go into a database and make a query and check the results of that. Today it's MySQL, Oracle, and Postgres. I think SQL Server is being worked on, probably DB2 at some point. But we can also talk to APIs. So we can connect directly to the AWS API. And you can do things like check the state of your users. Like, do all my users have two-factor authentication turned on, right? Are the AMIs that I'm using all based off of vendor-supported AMIs? Do I have this community Windows AMI that's spinning around inside my infrastructure that hasn't been patched in 4 years? People do that. And so the AWS Inspect profile allows you to write those compliance checks for the things that you probably care about as you're moving into AWS, or if you're already there. You can lock down those sorts of things, check your security groups, see what's coming in and out of your systems. We also do Azure, OpenStack, and VMware. So that's all out there today in open source. So any questions about Inspect? No? Okay. You'll see some of that in the demo. And then Habitat is our third open source project. And Habitat comes out of our experience with Docker. Right? As soon as we saw Docker, we said, you know what, that's awesome. Lightweight virtualization. We'll put the Chef agent inside a Docker container. And that's the wrong approach, right? That is like treating Docker as VMware, and it's not. It's something different. This is about 12-factor applications, about immutable infrastructure. And so we kind of stepped back and said, Chef inside of Docker is the wrong approach. And started looking at what people are doing with Docker. And the great thing about Docker is that it's a great packaging format. You have your application, you put it into a Docker container, and wherever you put it, it's going to run the same. Whether it's in Swarm, ECS, Kubernetes, it doesn't matter. You get the same behavior out of your application. And so thinking about this, we started digging into it and seeing the sorts of issues people were having who've been using Docker for a while. And one of the things we realized was there was kind of a hole in the story of how did you get that container, right? You ask people, what version of your application are you running? And they say, oh, I tagged it, it's 1.2. You're like, okay, that's cool. Oh, where did it come from? Is it secure? And they're like, oh, I got it from the Docker registry, and I ran some scans on it. Okay, that's great. Where did it come from? And the Docker registry, no. How is it built? I'm like, developer laptop? What version of OpenSSL was that statically built binary built against? And they're like, well, in February, right? And there have been a few SSL vulnerabilities since February. And so you kind of get to that question what's inside the box? And so the first part about Habitat is it's a build service. What Habitat has is a plan that describes your application. That plan says, these are the things that my application needs to be built with, and these are the things I need for runtime. And then it takes that plan, takes an empty Docker container with binsh, nothing else, and brings in your build time dependencies and builds a full stack version of your application. what you get out of that is a cryptographically signed artifact that has all of your runtime dependencies and a manifest. And a manifest says, here's everything I was built with, every compiler flag that was used, everything that went into it. Here are the ports that I need exposed. Here's how my logging's handled. Here's how my monitoring's handled. Here's how my health checks are done. You now have an immutable artifact, right? You have a full stack version of your application that can then be exported to Docker. So if you export that Habitat package to Docker, we have a Habitat supervisor that understands that format. It's just a cryptographically signed, it's just a signed protocol. You know, take off the header and it's protocol. Takes that, reads that manifest, writes up the Docker file, says these ports are exposed, I'm your pig one, I'm going to manage this application. These are the environment variables that I understand. I can pass those into the application for you. You now have an immutable artifact running inside of Docker. We also support CoreOS. We also support Mesosphere. We also support running right on a Linux file system without a container. What this means is if you're thinking, I've got these hundreds of legacy applications that I want to move into the cloud, but first I have to fix their builds. You can go and sort out their builds before you start thinking about, what's better, ECS or Kubernetes, right? You don't need to have that conversation yet. If you're already down that path, though, you have something that works pretty well. So you get this application, you know exactly what's inside it, which is nice to know. That Habitat supervisor has an API. You can query it. It can push data to the Chef Automate, so you can see the health of your applications. You can also, but you can also push config changes to it. Say like, hey, you know what? I've got these 100 containers running, but I need to change this one setting. So it can push that into the container and change that to be an environment variable. It also has a service ring, so if you need to do clustering, it can handle a little bit of clustering. For inside of Kubernetes, it can offload etcd. But that API kind of feeds into the third, that supervisor feeds into the third piece. There's a build service for Habitat. And what this means is when you define your application and how it's built, and all of its runtime dependencies, the build service, you throw your plan in there, and it says, oh, I see there's a new version of zlib. I'll rebuild zlib, and I see you depend on zlib. I'll rebuild you. I'll run any of your tests, including the inspect ones, any of your tests, and I'll publish that to an unstable channel, and then in the morning when you show up, you can be like, oh, passed all the tests, looks good, publish. The Habitat supervisor can do in-place upgrades of your application. Or the service can kick out your containers to your Docker registry, and you can replace them as you go. It also works on Windows. So the plans can be in Bash for Linux, PowerShell for Windows. So if you've got these .NET applications that you need to move into the cloud, we got something for you. Microsoft's contributing to it. We're working on that. So that's Habitat, not in the demo. But we kind of see this as like the future of Chef, the company, not the product. So yeah, any questions about Habitat? Anybody all in on containers? Yeah? All right, well, we have some very large container shops using it, so we're feeling pretty good about it. And it's really complementary to ECS. I did a blog post about ECS, works with Kubernetes, works with Swarm, works with Mesosphere, works with DCOS, works with pretty much all the container orchestrators. It's below that level. We just want to make better containers. Because applications are still kind of a black box. So this all comes together in Automate. And again, the goal really is just to help increase the speed and efficiency in which you move while decreasing risk. There's a nice clean distinction between what's open source and what's not. There's none of this, oh, you got to pay to get Active Directory integration, or the performance stuff is only in the paid. There's none of that. Inspect, Chef, and Habitat are completely open source. And we'll see what Automate looks like. But that comes into the Amazon story. So Amazon had OpsWorks. And OpsWorks was different from Chef. It was, there was a bit of a lag in how fast they released features. Some of the tooling was incompatible. We have a very large open source community, but Amazon has a very large user base. And so what would happen is people would start using OpsWorks, and then they'd say, oh, I got a question, I'll hop over to the Chef community. And they'd ask these weird questions like, hey, I need to talk to this AWS backend service. And people are like, are you using Chef? And so there was this kind of friction between the tools. the communities, a lot of AWS users, a lot of Chef users, and what Amazon was starting to see was when people got to a certain size, they kind of switch over to Chef, and that's not what they wanted, right? They wanted to keep them using the native tooling, and customers didn't want that either, right? They wanted to use a managed service. I mean, managed services are nice. It's one less thing you have to manage. And so last year at reInvent, Amazon came out and said, we've had a good relationship with Chef, and we've tried to get this OpsWorks thing to be more compatible. But you know what? We're just going to ship Chef Automate. We'll take the previous OpsWorks product and we'll call it OpsWorks Stacks. It's still there, but we're going to start migrating customers off of OpsWorks to Chef Automate, and we will offer that as a managed service. And so rather than have this mismatch of products, Amazon is now directly selling Chef Automate, which is our product. We're the engineering, working with them. They're your billing, support, get it right from the AWS dashboard, shows up in your AWS bill. It's free for less than 25 nodes. So if you just want to go nuts with 24 nodes, you're good to go. But what you get is a fully managed Chef server, so you don't have to manage that anymore. You get automatic backups and upgrades of all those components. Full compatibility with all of the tooling. And we are working with Amazon to, I'll go through the sign-up process here in a minute. We are doing upgrades of it. So it's not just like, hell, we stood up an OpsWorks, we stood up an Automate for you. It's a managed service that gets upgraded. Every 2 weeks you have a maintenance window, and in that time, you may get an upgrade of OpsWorks. So that's, and it's a native service. Part of the Chef server stack and Automate stack is, we're using Postgres and Elasticsearch and Nginx and Rabbit. All those get replaced with native AWS services and OpsWorks. So it's actually a native AWS service. It's a lot more durable that way. It's fewer moving pieces. And it works right out of your VPC. When you spin it up, you say, hey, I want this in an existing VPC, or I want to have it its own VPC, and you can open up those security roles to manage stuff not on AWS, right? So then you can have your on-premise stuff using a managed service on Amazon. Amazon's happy. They're getting that traction of lifting you into their public cloud, and you're happy because you don't have to manage 2 extra boxes and deal with upgrades and backups and all that stuff. So yeah, it's been a good partner, a good partnership. Currently, it's only available in North America and Ireland. I have several large Australia and New Zealand customers who are using it out of Oregon, and I'm in Amazon's ear about this, and so fingers crossed it will be available soon in Sydney and Melbourne if you're using those data centers and those AZs. Any questions about Automate? Or about OpsWorks?
Sorry, is this one automated with the New Zealand?
So what?
Is this product?
Amazon doesn't have an AZ in New Zealand.
The Chef Automate?
You can run it. You can run Chef Automate anywhere,
Oh.
right? But if you want it as a managed service from Amazon, you can only get it, in those AZs currently. But as we go through the demo, it's got everything, which is kind of nice. And yes.
Sorry. I'm quite interested in finding out the main differences between stacks and running the Automate.
Okay.
Like in terms of the layers and the stuff that's
They're pretty different.
I'm really super curious about how the Automate.
Yeah, they're pretty different, and Amazon's got some migration documentation.
Yeah.
So OpsWorks had kind of a different model. Where you define the life cycle of your applications. So you have when you start the application, do this, and you might have a Chef run list for that, run these commands, and then it would have running, and then if you have a reconfigure, and then there's a tear down phase, and you might have different run lists for each part. And that's a little different from how most Chef infrastructures manage. Usually, you define the policy you want. I want this box to run Tomcat with these settings, and and it was steady state, right? It would, first time it spun up, it would turn on a bunch of things, and then each time the chef agent ran, it would say, yep, it's still running those things, or, oh, there's a change, I'll update it, and I'll keep that policy enforced. And so there wasn't this end-to-end life cycle, and so that's the main difference.
And what about the layers? Because we found the layers were really good for people being able to see how an application stack was put together.
Yeah.
There's a really other key benefit of Stack. So is that kind of still there, or is that?
It's more, so within OpsWorks, we've got the concept of different parts of your infrastructure's layers.
Yeah.
And so that model didn't really take off that much in the rest of the chef community. Usually you have a run list, which is the list of the chef recipes you want applied to those machines and the order you want them in.
Yep.
And so the layers kind of just say, well, if you want to set up the base operating system, that's the first thing in your run list. And if you want to set up the middleware, that's the second thing. And then the application would be the end, and then it would just go through those in order. And each time, it would just push that through. But then there are access controls over everything in Chef. And so what some shops do is they might say, like, hey, infrastructure team, you guys manage the base operating system. You're only allowed to touch this cookbook.
Yeah.
So you control the base OS. And hey, middleware team, you know how to stand up your app. You're only allowed to touch this cookbook. And application teams can only manage their own pieces. And so you have that run list that was pinned down, and the people would only change the parts of that they care about. And we'll see some of that in the demo, and I'll talk to that. But yeah, there's Amazon's got some migration docs about upgrading across.
I might talk to you offline.
Sure.
Yeah.
Yeah, we're happy to help. Yeah. So yeah, that's the current state of it. And it's going well. It's a good partnership, and we were actually the first company to have Amazon manage someone else's product on their cloud, right? I mean, they were taking things like Elasticsearch, and there's a company called Elastic, and they were like, that's a great product you got there. Here's Elasticsearch as a service, and that was, and there are lots of other examples like MySQL, RDS. They work closely with Microsoft on the Windows side and the SQL Server side, and of course with Oracle on their database stuff. But we were the first open source company to kind of get that partnership thing going, and it's working well because now instead of having to worry about somebody taking your open source stuff and selling it and you getting nothing, we're partners. And so we're Amazon people. Amazon's never been afraid of competing with themselves, so we overlap with a lot of other AWS products like Code Deploy. Some of the other ways to deploy nodes, but Amazon has a lot of services, right? And so kind of the way you end up using Amazon is based on the way someone showed you how to use Amazon. And so it might be literally it might be like I don't know how Bulletproof does it, but maybe they're like, this is what we like, and that might be different from what the next consulting shop over does. So yeah, we do overlap with some of Amazon's products, but we are an Amazon product. So everybody gets 2 pizzas and we move on. So yeah, OpsWorks. And so it literally, if you're in Oregon, I think this was me logged in Oregon. If you go to the OpsWorks, you go to the landing page and it says like OpsWorks for Chef Automate, OpsWorks Stacks, and then you click OpsWorks Chef Automate. It's there. You click Create Chef Automate Server. Put in the name of your server. Right now you can only do it in Oregon. As sizing recommendations, we've got a sizing document coming out around this in case you need bigger than 500 nodes. We do have, we had a customer at ChefConf, our user conference, talking about, I think they were doing about 3,000 nodes on OpsWorks. And they love it because their business was very siloed, and they could just say like, you guys are over there, you guys are over here, but we all use the same tooling, and it's not something we have to manage. You throw in your SSH keys, the VPC, the subnet, whether or not you want a public IP address, generate a security group or use an existing one, roles, instances, go through the review, click go, and it's like, hey, check back in 20 minutes. Because it's actually standing up a fair amount of infrastructure. It's got a cloud formation template in the back end where it's, putting up the VPC, RDS, ELB, all those, getting you a public IP address, binding it, all that fun stuff. But then when it's done, it says, here's your admin credentials. This one's not there, so I'm not worried about it. Here's your password, here's your credentials. Go in. You can go and download the Chef Developer Kit and the Starter Kit. Documentation is there to get ready to go. This works with all of the standard Chef tools. We work closely with Amazon to make sure it works. And then you hit the IP address and you say, hey, it's Chef Automate. Paste in your password, and it says, welcome to Chef Automate. Would you like to take a tutorial? Would you like to have the tour? And you're like, I already know what I'm doing. And then you're in the live environment. So I will switch over to the demo now. And so I've got OpsWorks running. I've got Chef Automate running on AWS. I've stood up a Windows workstation on AWS, so I can have that Windows developer experience, and that way I don't have to set it all up myself. And so this is the Chef Automate dashboard. And if you're doing configuration management, this is the kind of stuff you'd like to see. Automate supports, it's multi-tenant, so I could drill down into different organizations if I'm managing multiple customers from one infrastructure or different business units, and you keep them separate, but you want to keep tabs on all of them. Chef Automate also works with Chef Solo. So if you're using Chef, you do not have to use a Chef server. Some people like to use Chef Solo, which is a kind of a fire and forget model for Chef, where you might have some boxes that are just, they're going to stand up and you're never going to touch them again. That's a common use case, but you might want to know some of the health about them or maybe their compliance state. And you get nice trend graphs about the state of your machines. I turned off the machines checking in, so it stopped. And you can filter down on all of it. And this is my demo environment. So I've got 8 machines running in my environment. 3 of them are build nodes for my continuous integration, continuous delivery. One of them is a testing node that I'm using on my laptop. And then I have these 4 machines that are each running a MySQL, Java, Tomcat, Apache, OpenSSL stack.
So just one question on the multi-tenanted thing.
Yeah.
Can they be in separate AWS? So you've got Chef running in here, like so you're using the consolidated running, or can they be across different AWS?
They sure can.
Cool.
Yeah. As long as machines can access the Automate server via SSL 443.
Yep.
That's all you need.
Yeah, cool.
Right? So you just open up SSL and the clients are checking into the Automate server. It's 2 lines you add to your Chef client RB file, the token you use, and the hostname and port, whatever. And that's all you need. And so it's a fairly simple configuration setting. There's a Chef cookbook that will manage it for you.
Yeah, so it's just like normal Chef because that's how Chef used
Yeah.
before. So that makes sense.
No, that's a good question. Like, if you have Chef questions, I'm happy to dive down into it. So we've got these Tomcat boxes, and if we drill down into one of them, we can see the state of the converged status. This machine is managing. Looks like it's got 61 resources. 61 things are being managed to stand up that Tomcat application. Over here, we can see over the last 24 hours, we've checked in 25 times. We also see that one of those times there was a failure, right? So the first time this Chef client ran on this machine, there was a failure, and so I can see that error log directly here, and it says, "Hey, we failed because a remote file wasn't available." As I stood up the demo environment, there's some timing. Things weren't available yet, but I might need this for debugging, and I can also see all the things that successfully did run. As well as the diffs of the config of various files that Chef altered. It's the kind of stuff you'd want for config management. You'd want to know what changes, when it changed, who changed it. And so if we go back to the latest run, we see that this machine is kind of hit steady state. 55 resources are unchanged. So each time it's just validating that policy. And it's running a couple commands around how Apache's set up just to make sure it's running. And we can see the run list. Yeah, question?
So, another question. So how does this handle like dynamically scaling posts? Like, an auto scale group of web servers behind, because that was one of the challenges we had when we just ran Shift.
Yep.
Designers that pretty much expected static posts to be there. It got real complicated when stuff was scaling. So what's the deal there?
So what you want to do is, in Chef, there's a couple layers of hierarchies, right? You've got your organization, which is everything inside it. And then underneath that, you've got environments. And your environments might be things like, Data Center 1, Data Center 2, or production, QA, pre-prod, that kind of stuff. And in those environments, there's an environment file where you can define attributes. And you can say, if you are inside Data Center 1, here's some attributes that you're going to use. And one of them might be, here are the credentials for the Automate server that you're going to connect to. And so when that node, that auto-scaling node spins up and says, hey, I'm installing Chef. I know the Chef server I'm going to talk to. I know that I'm going to write out my client config file. You can use Chef to configure itself. You might actually pull those environment settings, write them to your client RB, and now you're talking to Automate. And so as those auto-scaling nodes come and go, they're automatically checking themselves in.
Yeah.
We don't currently support auto cleanup. That's something that we're working on, right?
Because I think that was the trouble I had. It wasn't so much nodes provisioning, that was when they went away. It started getting real nasty.
Yeah. I mean, there's some scripts you can run, but we want to make it like an automated process.
Because that's the other thing that's
but so this is the config management side of things. We can see various attributes about that machine. I can search through those and say, show me information about the CPU. It's like, oh, here's the CPU. It's Xeon 2670, and any of these attributes on that machine. Some of them are automatically detected, like the CPU. Some of them are dynamic, like hostname or IP address and that kind of stuff. You can use those in your Chef recipes, though. These can become parameters. So maybe you say, hey, if I'm on a box with 16 gigabytes of RAM, the pool size can be 14 gigabytes. Or, but if I'm on 8 and I set it to 14, I'm just going to blow my stack every time. So you can be dynamic about that, which is kind of nice. You might use Ruby for that inside your recipe. Yeah.
Good question. Does Chef Automate handle complicated hierarchies?
Yeah. Depends on what your definition of complicated is.
Sometimes I would like to have an environment hierarchy, and then under environment hierarchy, I would like to have specific roles for each.
Yeah. So going down that hierarchy, right? You've got the organization, which is a node belongs to one organization. It belongs to one environment, and then we have the concept of roles. And so the roles allow you to say, this machine is a web server. And the way you define a web server is, well, it's got the Apache cookbook and mod SSL recipe in it, and it's also got Tomcat cookbook. These are this is the run list for it. But that machine might say, well, it's a web server, it's got that role, but it's also a hardened OS, and so that's another role you could use. And so you can use roles to kind of separate the parts of the run list that you want, and then just aggregate them together with well, first we're a hardened OS, then we're a web server, and then we're also a Dropbox or something like that. And so you might have different roles that represent those as abstractions. So usually in Chef, you're going to be working with roles rather than directly with individual servers. You're not going to say, hey, EC7213, whatever, I want you to be a web server. You say, look, you're a web server, take this role and run with it. And so those roles can contain other roles. And so you can build up any sort of abstraction for what those boxes look like and just use that to manufacture those out. And those roles can also have attributes. So you can say, if you're hardened, you get these settings, but if you're in the this data center environment, you get these other settings. So there's ridiculous levels of hierarchies you could put in there. Most people, and then the attributes can have different levels as well. There's normal, there's default, normal, and override, and then those can be set in the role, on the node, in the environment. Most people don't mix too many, but there's 12. Maybe there's 16. Anyway, there's too many. Most people don't use all of them. They only use like 3. So yeah, there's definitely ways to get really fine-grained on all that. But yeah, so that's the config management side of things, right? And so this box is going along, and of course, with these attributes you gather, there's a discovery agent on that the Chef agent uses called OHI. It's pluggable, so if there's more stuff you want, you can add more stuff. Like maybe you're still in a data center and you want to pull the service tags off of the machines, or maybe you want to say, hey, this is the developers who are allowed on this box, and push that data into this node. So later on, when you're generating reports against this, you might want to pull that up. But essentially, what you get is like a real-time CMDB. So anytime you want to query your infrastructure, you've got real data about what's actually on the box. It's not what you wish was on the box. And it's dynamic, because some of these machines are going to come and go. And one of the nice things about Chef is it uses these attributes and search heavily. So you might say, hey, I'm an app server and I need to talk to the database. Where's the database? You ask the Chef server, where's the database? It says, oh, here's the IP address, here's the port, here's the credentials. Go talk to that guy. And then it's Amazon. That database disappears, and another one, you're like, oh, I lost that box. Let me spin up a replacement. And then in your app server is like, where's my database? Where's my database? Ask the Chef server, where's the database? Oh, here it is. Rewrite your config file, restart your services, and now you're talking to the new location. And so as stuff comes and goes, like it does in the cloud, Chef works really well in those dynamic environments. Load balancers, Nginx looking for, or HA proxy looking for things that it's balancing, that kind of stuff works great. But that's the config management side of things, right? And so, that's kind of stuff you'd expect to see. And then, you're managing your infrastructure with Chef, and you're pretty happy about all this. And you get that dreaded email from your boss, because, they were watching the news at the airport, and they saw that there's some new security vulnerability going around that made the news, right? Anybody's boss called them about WannaCry, right? Poodle is a real attack. Poodle is a real attack from back in May for OpenSSL. It took advantage of some known vulnerabilities with SSL 3 and TLS 1.1, and so the fix is like turn those off, right? So you get this email and you're like, nuts. How am I going to solve that? Well, luckily, there's also this tab over here called compliance. And this is where inspect comes in. So we've got those 4 machines that are running that Tomcat stack. And if we look, we can see that, hey, your system is not compliant. You don't want to see that, right? And we can see that, I spun up this demo environment and it probably was failing compliance checks. I can see that all 4 of the boxes are Ubuntu. I can see that the environments are, Union, Acceptance, Rehearsal, and Delivered. Those are the names of my environments. They also happen to be the stages of the CI/CD pipeline. I can drill down into those profiles and see which controls are failing. I see that it's the SSL2, SSL3, TLS 1.1 checks that are failing. I can actually go to those individual nodes and see the results of those scans. And so I've got this SSL check, and I can see that these boxes are good, and the fact that TLS 1.0 is turned off, that's good, and 1.2 is turned on, that's good. But I do have TLS 1.1, and I can see here is the inspect control for that. So this is a little bit of inspect. Disable TLS 1.1, impact 0.5. That should probably be a 1. The command, we're just calling OpenSSL client, connecting to those boxes, and checking the standard out for secure renegotiation is supported. That's how you see if you run SSL. TLS 1.1. And that's when these attacks come out, this is what they tell you to do. log into your system, see if you have this patch installed, see if you get this response when you connect to a box. And so this is the inspect code. The actual results of that, sorry, I turned that off. The actual results of the call are here. So if you actually wanted to see, the command line version of inspect, what's coming out of that is there. But what that's generating is this nice handy report that says, hey, here are the 5 things we checked. 2 of them passed, 3 of them failed. What are you going to do about it? Right? Well, what we're going to do about it, because it's Chef, is we're going to spin up Visual Studio Code, nice free IDE from Microsoft, open source. And we're going to take a look at the Chef recipe that set up this Tomcat stack. I've got a default recipe. This is their runs. Essentially, they just call this recipe, and this recipe calls other ones. Install Java, SQL, Tomcat, shopping cart, and SSL because it's a shopping site. If we look at the MySQL cookbook or recipe, let me make that a little bigger. This is a little bit of Chef code. We're taking a list of MySQL server, a SQL client, iterating over that list, and calling the package resource against that. So we're installing those 2 packages. And then we're creating the schema from the command line for this MySQL database. And then we have a check that says, hey, check and see if that schema is installed. If it is, don't run this command. Right? You don't want to keep blowing away your schema every time. And that's the policy. It's pretty straightforward. If we look at the SSL recipe, Pearls of Live Diamonds. Oh, come on. Come on. What the heck? How hard is it to open the file? Alright, let's try this again. It's a great editor, really. All right. Well, I'll hop over to Emacs and show it to you. I'm sure it'll pop up soon. That's weird. All right. Well, hopefully it'll come up soon. I'm going to need it to come back so I can actually patch it. But I'll talk about it here in a second. That's off the screen. That did make it better. So this recipe is fairly straightforward. We're going to install Apache and libapache myjk. So we're setting up Apache and installing Tomcat support. We're going to enable the JK, the Tomcat module and the SSL module, and turn on SSL. We're going to put the Tomcat 7 service on here, the Apache service, and we've got this template for mod SSL, right? If you've set up modules for Apache, this looks pretty straightforward. It's a templatized version of the SSL conf file, and whenever this file changes, it notifies the Apache 2 service to restart. Right? That's our policy. So hopefully, come.
You need to type Visual Studio.
You think so? Or you know so?
It's just you.
Notepad?
Yeah.
Yeah, you're probably right. Man. It's a great editor, really. I mean, the reason I use it is because most Windows people are familiar with it. But what the heck?
I don't know this guy on my machine.
That would be bad. glutton for punishment. Here we go. Okay, so there's our recipe. And we saw that SSL conf file. That's the offender, right? That's the one that's setting up SSL incorrectly. So we'll go over here to our templates and go to this SSL conf. And luckily for our demo, right here at the top is the change I need to make. I'm gonna turn on the SSL protocol. I'm gonna disable all the protocols, and I'm gonna turn on only TLS 1.2, right? And I'm gonna turn on these known good SSL ciphers. I'm not gonna use any RC4 or any of those known bad ones. So that's my patch, right? But this Chef Cookbook, it's a library, right? If you're thinking about your infrastructure as code, it's a library. And so I've got a patch that I'm going to deliver, so I'm going to bump the version for my cookbook here. So if we drop back to the command line, and I say git diff, there's one patch, two patch, right? And so if I want to deliver my patch, first thing I got to do is I got to make a feature branch for it. If anybody's used Git, you've probably done this before. You make a little branch for your patch. And I could just send this straight into the CI/CD, but this is Chef, so we have a tool called Test Kitchen, and what I can do with the Test Kitchen is I can actually run my test locally on my laptop. I can take the code that I'm using to manage my infrastructure out there, in production. I can run on my laptop and make sure that this patch actually does what I think it's going to do. And so in this case, Test Kitchen works on top of Vagrant. So if you've used Vagrant before, that's probably a familiar experience. You got that, developers deploying code to their laptop. Vagrant and Chef work really well together. Test Kitchen can also work with cloud instances or virtualization instances as well. In this case, since my workstation's on AWS, I can't do virtualization on virtualization, so I'm using another EC2 node to run my Test Kitchen stuff. So there's my patch, right? We see this happen, and then we see that the Apache 2 service restarted. That's what you expect to see. And I'm like, oh, that's pretty cool. Let me actually run those inspect checks locally so I know that I'm going to pass that test before I just push this into CI/CD and it fails and I waste somebody's time. And maybe my patch would work the first try. But it does. So there's all the tests running. If I successful, I'm like, all right, this is a great patch. So I'm going to go ahead and git commit my patch, all the files with message, fixes, known SSL issues. Right? And the command line for our CI/CD is called delivery. And so I'm just going to submit this patch for review. And so, when I mentioned that Chef overlaps, or Automate overlaps with some of the features available in OpsWorks, one of them is we have a CI/CD built right into the system. We can definitely work with other tools. We're not, we realize that most people are going to use Jenkins, or maybe they'll use Code Deploy, maybe they'll use Microsoft's tooling, a lot of choices. When we wrote our CI/CD, the choices weren't very good. And we were going to build something on top of Jenkins, like everybody else, but we actually hired Jez Humboldt, who wrote the book Continuous Delivery. So that was fortuitous. And so we hired Jez. He also wrote DevOps Handbook. DevOps Handbook. He's one of the authors of that. And he's gone on to go back on the consulting roadshow. But we feel pretty good about this CI/CD. Because this is the general shape that most people are going to end up with, right? Eventually, they all kind of converge into something that you recognize. For our CI/CD, the first phase is called verify and approval. Verify is we're going to run a bunch of automated tests. As many automated tests as you can, we're going to push those into here. Unit tests, lint tests, syntax tests. And then you're going to have a reviewer, right? In this demo, I'm going to review my own patches. You don't want to do that. What you want to do is what we call the law of 4 eyes. You want to have someone besides yourself, 2 other people review your code, right? It's just good hygiene. But I approve my own patches because it's a demo. Automate can enforce that. Automate has the ability to map out your work inside of here. Right now, we only support our own authorization. We can do authentication with LDAP and SAML and single sign-on stuff, but we don't map those orgs into Automate yet. It's being worked on. So then we'll be able to take Active Directory and bring it in here, and you won't have to recreate your teams. But for today, we do. And then this build step is actually taking that patch, rebasing it onto the master branch, rerunning all of the tests. Assuming those all pass, we're going to promote it into acceptance. And this is where we actually start running on real machines. And so this provision step, this is all pluggable. So in this demo, a lot of this is just turned off for speed. We're not running a lot of tests. We're just blindly promoting it. But we could turn these things back on. This provision step, we could actually kick off a CloudFormation template, right? And stand up 10 nodes and actually go and test those 10 nodes with our patch to make sure that our application is well behaved in a real environment, not just running unit tests or test kitchen with one box. This is pluggable. You put whatever you want in there. Terraform, CloudFormation, Chef, whatever you want to use. We're not possessive about that at all. And when this is done, we have another review. This might be a different set of reviewers. This is actually saying, passed all the tests, we're going to release it to production. So this might be your release team, your security team, maybe one reviewer from each team. We can support that as well. But in the back end of this, there's this whole code review process. Just like you've done with GitHub, with Stash, with GitLab, with Bitbucket. I think right now this is only works with GitHub. It's bidirectional. So I could do my code review in here and say goodbye, poodle. It supports emojis and all that fun stuff, because that's what people want. You can embed YouTube and whatever and whatever. But you do your reviews, you deliver the patch. The union phase is if you have any downstream dependencies. You can say this pipeline is my base operating system. The middleware depends on the base operating system, and these 7 applications depend on the middleware. And so what happens in the union phase is it kicks off any downstream test with your patch, make sure you don't have any regressions. Assuming that passes, it goes to the rehearsal, which might be a different set of infrastructure. Maybe you test on with CloudFormation, but you actually deploy the VMware, or OpenStack, or physical boxes, or vice versa. And then delivered is actually pushing it to production. When that happens, the Chef agent has that new version, and it runs those SSL checks, and your compliance dashboard turns green, or blue in this case. And so those nodes are all passing their tests now. We're passing that SSL check. If we go and look at any of those individual nodes, we can see, I think, which one? This one. This is the one that had the patch. There's our patch getting deployed. There's our SSL check. There's a patch restarting. Now we're back to healthy dashboards and reports. Everybody likes reports. You can download the health of all your compliance stuff, hand that to your security officer in the morning. Like, hey, we ran these 107 controls every day. Here's your security report. This is all included in OpsWorks for Chef Automate. Yeah.
Could you push that out in stages to specific sets of nodes?
Mm-hmm. Mm-hmm. Yeah, so you might, I mentioned the environment files are managed, those are code too. So you might say the environments allow you to pin the versions of Chef cookbooks that are deployed into them. So you might say, over here in production, we're pinned to 1.1. I'm going to roll out a deployment into data center A, and we'll bump data center A to 1.2. Make sure we like how that behaves, and then we'll upgrade it and go through that whole approval process again. So yeah, you can totally stage things that way. Yeah.
So, for this scenario, those changes are applied to running nodes, right?
Mm-hmm.
Can it be done so that
Ephemeral?
blue-green?
Yeah, totally. So I kind of glossed over in the pipeline the provision step. at the end of that, you can say destroy that environment completely. Or the provision step might be, let's blow out the old QA and replace it with a completely, green, completely new QA. And if we like this, the provision step in the next stage is let's just take that one and change it over to production, and blow out the old one. So you can, do blue-green deployments that way. It's pluggable. It's meant to be. The shape of the pipeline isn't really supposed to change, because what you want to do is have a pipeline that's familiar, and you can have lots of different teams use the same structure. So, I mean, if you're using Jenkins, if I say, hey, go build a Jenkins pipeline, and then I say, you go build a Jenkins pipeline, you're not going to end up with the same pipeline, right? And it's like I hand you a stack of Legos and say, build a house, right? You've got 4 windows, you've got 27, right? Ours always looks the same. You can have it any color as long as it's black. And all the things inside of it are pluggable. So the sorts of tests you're running, what sort of approvals you need, you can segment all that. And so you can say, like, this pipeline is only accessible to the base OS team, right? Everything in Automate and Chef have access controls and rules on them. And what comes out of that workflow is an audit log that lets you see who did what to what systems, who approved what, the output of the tests that were run. All this is just sitting inside of Elasticsearch. We have an API. You can push it into logging, send it to monitoring, send it to ServiceNow, whatever you want to integrate it into. That's a lot of really good operations data to have. And if you're in a highly regulated system, you probably want this kind of stuff.
One more question. So, with regards to the pipeline, do I need to create the pipeline on the dashboard, or is there something like a Jenkins file where I can write the pipeline on my code base?
Yeah. I mean, the pipeline is completely defined in code. There are a set of, we go back to the dashboard. There's a set of Chef cookbooks that are just like, this is the verify step. Here's what it looks like. Would you like to customize it? Here is approval. Here is build. And so if you look at something like this SSL one, if we go back to the verify step, this is a Chef cookbook, so it's using for unit tests. It's going to use Chef spec for lint tests, food critic for syntax checks. It's going to use cook style. But if you were doing a Java pipeline, it might be like JUnit, JLint, Java C, right? So you can plug in different tools here, but the shape of the pipeline can't really change. You can say master branch or some other branch. You can set up the dependencies, but this is the flow.